Okay, a little late getting this one up and ready for everyone, but if you had to use the old video, so be it. But this will be a new video this year on the confidence intervals, going to go over this. I would say make sure you have your current formula sheet, formulas and tables for AP statistics. One main thing we're going to look at today is confidence intervals. So the confidence interval formula is the statistic plus or minus a critical value times the standard error of a statistic. Now, the critical value, that is always, in terms of our problems, it's either a Z star or a T star. Okay, so how do I know? Okay, remember when we're dealing with proportions, proportions always use Z's. Means will always use T's. One of the ways you can remember this is you have a calculator on the AP exam. So whatever calculator you have, you can always use that if you've forgotten. And you can go menu 6, 6, and you can look at all the intervals. Now, we have never used number 1 and number 3. We've never used them. Okay, so there's not going to be a Z interval or a 2-sample Z interval in terms of statistics where we take samples. Those situations would occur only if it said something like the population is known. And so we don't even cover those in that situation because on the AP test, they're going to do a T interval for the means or a 2-sample T interval for 2 means, or when we're comparing 2. 5 and 6, the 1-prop Z interval, 2-prop Z interval, we use that. Now, the linear regression T interval, typically that one doesn't get used. So the ones you have to be familiar with are 2, 4, 5, and 6 on this page. Okay, proportions are Z's, means are T scores. All right, so your statistic, what is your statistic? You can find all your statistics on this page when we're looking, there we go. On this page when, sorry, I can't find my little arrow so I can drag this thing. We'll just move it this way. All right, so your statistics are your proportion, P hat, or if you're doing 2 proportions, P hat 1 minus P hat 2. That's what will go in this area of statistic if you have to use the formula. Typically, we don't use the formula when we're doing them on the AP exam. I will talk through the formulas. Otherwise, we have X bar, and for the 2-sample t-test, we have X bar 1 minus X bar 2. For slope, we use B, and I'll tell you right now, we have never used the standard deviation when we're dealing with slope. Now, the critical value, if you're using proportions, it's Z star. If you're using means, it's T star. And then your standard error of your statistic, if you're finding a single proportion, here's your standard error of your statistic right here. This is the standard, wrong one. That's it. That's for the population. The standard errors are all over here on the right. So it's this side and this side. This side and this side for this one when we're dealing with 2 proportions. When we're dealing with the means, here's X bar, the mean, and its standard deviation, S over the square root of N. X bar 1 minus X bar 2 if we're doing 2-sample, and then we've got the square root of all that stuff over there for this one. Now, why don't we use this one? We're typically dealing with a linear regression printout. I don't remember if I have one on here. I might have to do that. But let's jump in. There are 2 steps when we're doing confidence intervals. So you have to make sure, I always made them worth 6 points on tests. You have to do the assumptions, and then you have to do the interval. And don't forget the context sentence. I am 90% confident the true mean is between this and this. What is a parameter? It's the value we are trying to estimate for a population. So for example, it may be a mean, it may be a proportion, it may be a difference in means or a difference in proportions. So we're going to jump in here and we're just going to look at this. It says we're trying to estimate the proportion of students that feel prepared for the AP exam. So the parameter, what is that? It's a proportion of students that feel prepared for the AP exam. Now, why is that important? You would use that in your confidence interval sentence. I am 90% confident the true proportion of students that feel prepared for the AP exam is between, and then we would give the two values. Okay, it says what is our confidence level that we're looking at? We're trying to do 90%. Okay, we find that 70% feel they are prepared. So the name that we're going to use, we would use the 1 prop Z interval. Okay, so if I'm going to do a 1 prop Z interval, it says construct and interpret the interval. So I've got some space here. What are my assumptions? Now, this is something you have to memorize. Of course, I have these where on another page where you can memorize them. But if you don't have them memorized, it should be pretty straightforward. The 1 prop Z interval, of course, we have to sample randomly, independent. Each value has to be independent from the next. The sample has to be less than 10% of the population. You shouldn't sample too much. That's never one I check for, because if you talk about independence, that's part of what affects independence. So if we've assumed independence, we usually leave that off. Then n times p has to be greater than 10, n times q has to be greater than 10. You can actually multiply the proportions, or you can just come up with the number of successes and the number of failures and see that that is there. Then you have this sentence, I am such and such percent confident the true proportion of something is between something and something. Okay, so I'm not going to go through this every time, but I will look at the formula sheet, but let's jump in. So typically 3 assumptions that we want to have. So I would say, all right, random, independent, and then we have this 70%. They have 70%. Now to find out how many that is, you're going to have to take 40 times 0.7. We would get 280. Now you could put this in your work, and I would suggest if you're multiplying it anyway that you would do that, but we have 280 successes, which is at least 10. If we subtract, we get 120. We could also take 400 times the opposite percent to get that 120. But we have enough successes and failures. Now remember, anything with proportions, you have to have 10 successes and 10 failures for every group you're dealing with. So it is now nearly normal. So you need to address that. Now you've got your assumptions point. Okay, now on the AP exam, I would just say 1 prop Z interval. I'll do the formula, but I'm going to do that last. Next, we'll say I am 90% confident the true proportion of students that feel prepared is between, and now you grab your calculator and you do your interval. So in our calculator, we go menu, 665 if you have an Inspire. And remember your X value it was a nice, neat number 280. If it had been something else like 279, you cannot have a decimal X value. You're going to get a domain error in that. So make sure whatever you put in for X, just go ahead and try that, get that error now, and realize that you have to round here and make it nice and neat. But it's between 0.66 and 0.74. We'll just round those to nice, neat numbers. Okay. Now, how would I have done this on the AP exam if I needed to fill those things in? My confidence interval is my statistic. I would have taken p hat, which is my 0.7, my 70%. Okay, I know that I'm dealing with a proportion, so I have to use Z star. So you have to get your T-table sheet. Your T-table sheet in the AP exam, it's in the back. It's really the only one you're going to use. We don't use the chi-square sheet, really. We don't use the Z-table at all. Don't even teach that. That is the normal CDF function. So you go in the back and you find that's 1.645. It's that bottom number. The degrees of freedom are ruled out. We're not dealing with a T star or anything like that. Then times the standard error of the statistic. So in that case, I look that up, and that is p hat times 1 minus p hat. Now, a lot of times I use q hat. It's a little shorter than the 1 minus p over n. But we find that here, p hat, 1 minus p hat over n. Okay, so if we were filling this in on the test, 0.7 times 0.3 over sample was 400, I believe. And that's how you would fill that in. All that gets covered if you say one proportion Z interval. On the AP exam, the way they grade it, they will say you either have to, by name or by formula, say what you did. It's on your calculator. So my suggestion on the AP test is that you only use the name. The formulas will be helpful, that you know those for the multiple choice portion. Okay, now the next one. How large of a sample would be needed to cut the margin of error in half? Remember, in this whole formula, there's a 400 in here. Okay, so to cut something in half, we'd have to divide by 2. I'm doing a little replacement work. Instead of a 2, since that number's under the square root sign, I'm going to put a 4 under here. And the idea to cut the margin of error in half of what we just did, and actually of anything, you would have to take the sample size times 4, because that would end up putting a 2 in the bottom. So we would need a sample of 1,600 based on this one. How large to cut the margin of error to 0.01? For that, I'm going to need to know what the margin of error is. And the margin of error is 0.0376. This one, actually, I don't need to know what the margin of error is. I need to know the margin of error formula. Now, going back to, our formula sheet. Our formula is on the last page. That's the standard error. When you put Z star in there, that is the margin of error. So we use this formula where the margin of error, we want to cut it to 1%. I'm going to do this one down here since I have a little bit more room. And we did a 90% confidence interval, so 1.645. We know that our best guess is 0.7 and 0.3, and we need to figure out n. So this is one of those problems where you have to solve for n. Now, typically what I did is I would multiply by the square root of n and get that over here. And then you would have 1.645 times the square root of 0.7 times 0.3 over here. And then we turn around and divide by 0.01. Okay, so we'll do that. Again, this is a review. If this is something you need a little bit more help on, sure, you can, of course, contact me. Whoops, I don't know what I did there. Need to make sure I have my glasses on. All right. Square root 0.7 times 0.3. We'll divide that by 0.01. All right, 75. And then we're going to square that because that gets us the square root of n. So this is the case where you always bump it up. It's 5,683 would be our expected n that we need to get this done. So that work. Quite a big sample to get that done. That's why most of the time in samples, they don't make them that big. Okay, this one, in an effort to find the difference in proportions, that's the difference in proportions of students that are doing their work in AP classes. So what's our parameter? Difference in proportions of AP Stats and Calc doing work. Confidence level that we want, 95%. You look that up in terms of, we know we're going to possibly need a z-star. If we look that up, 1.960. The name of this is the 2-prop z-interval. I'm going to only write it once, because if I've got it written here once, we got the idea. What are our assumptions? Now you can go to that last page, but I'll be doing them here. So random independent groups. The way I have us do that is talk about the fact that there's plural, 2 groups, that they were both sampled randomly. There's independence within and between the groups and all that stuff. And then we have to talk about in 100 AP stat students, 85 are doing their work. So we need successes and failures for both groups. So 85 is greater than 10, 15 is greater than 10. And then 75% of the Calc students are doing their work. So we take 0.75 times 200. Got to figure out what that is. That ends up being 150. And that's greater than 10. And you find the number of failures, that's greater than 10, 50, who are not doing their work. So that is nearly normal. Now, whenever you have 2 groups, you're taking one group minus the other group. We have 85% of the stats, 75% of the calc. I am 95% confident the true difference in proportions, stats minus calc, is, or that are doing their work, I'm just going to say DW, doing work, is between, and then you're going to get 2 numbers. Now remember, this is a difference in proportions. So we jump on here. Menu, statistics, confidence intervals, 2-prop. So we have 85 out of 100 for the stats. We have 150 out of 200. And again, remember, none of those can be decimals in terms of the X. We do 95% confident. 0.95 works, 95 works in the calculator. I don't know why they set that way, but it's kind of nice. But it's 0.008 to 0.192. Okay, so is there evidence of a difference based on that? Yes, because 0 isn't in the interval. So they can't be equal as a result. It's all positive. So that would say stats is doing a higher percent. Okay, now if we jump to the formula, we'll jump to here. How do we use this if we're on the AP exam if we need it? Remember, I would advise you on the open response portion just to put 2 prop Z interval. Okay, but if you look up what is the statistic, it is p hat 1 minus p hat 2. If you go down on that next page, your critical value is a Z star. So if we're filling this in, we had 85% minus 75% plus or minus 1.960. The standard error of the statistic is p hat 1 times q hat 1 over n1 plus p hat 2 times q hat 2 over n2. Remember, the q's are 1 minus p's. So if we fill this in, I'm running a little bit out of room, but it'd be the square root of 0.85 times 0.15 over its 100 plus 0.75 times 0.25 over 200. Again, all that gets covered on your question when you say 2 prop Z intervals. So I wouldn't do that. Hopefully these formulas are making a little more sense. Getting where to look at that formula sheet. Okay, so now we're getting into means. So this will be the X bar one if you're going on the sheet. A company wants to investigate whether they should invest in a new machine if the new machine can outperform the old machine by at least an average of 8 more. Their investment will be justified. Their old machine can produce a mean of 32 parts per hour. In a random sample of 45 hours of work, the new machine had these numbers. So I've already put these into the calculator. We would put them in to a list and spreadsheet, and I called it X. Hopefully I got the right ones in. I think I do. Okay, so what is our parameter? It is the mean parts produced. Now, since this is mean, remember, you're going to use a T-star if you do the formula. On this part, I'm not going to say anything about T-star. I'm not going to use the formula. We're going to say T interval. That's all we're going to say. But our confidence level is 95%. Okay, so you do need to get your T-table sheet, and you need to look that up. There are 1, 2, 3, 4, 5, 6, 7. So in terms of degrees of freedom, it's n minus 1 when you're dealing with this. And that's our T-star. We'll look at that later. Okay. Again, I don't really need that right now. But what are our assumptions? Random, independent, and then nearly normal. When you put stuff into a list, you should look at your normal probability plot. But I usually say if they've given it to you, it's probably going to be normal. You don't want to take that chance. That's fine. It's usually a pretty safe bet for me. Menu 1-4, normal probability plot. And it looks straight enough to me. Yeah, I kind of see the curviness, but I'm going to say it's normal enough. Okay, so I've made a little sketch and said nearly normal. All right, so what's my mean? It's a T interval. If you say T interval, that's fine. Technically, T interval for a mean. Okay, so I am 95% confident the true mean parts is between 662. We have the data because we typed it into a list. I have it in that list. Not much else I need to do. Click the 95%, and it should be 34.3 to 48.3. Just make sure I read that right. Something in my head said I didn't quite read it right. 34.3 to 48.3. Yep. Okay. Do you recommend they buy the new machine? Now it's 32. They're saying it has to be at least 8 better. So it'd have to be at least 40. Okay, so no. The interval contains 40 and isn't guaranteed above 40. Okay. Now the margin of error for this one, if we're doing the formula, let's jump into this one in terms of the formula. So we'll go over on here again. What is our statistic? I'm getting tired of erasing that. So our statistic this time is x bar plus or minus t star times s over the square root of n. Now, whenever you take one of these in terms of the formula for going down here, that's the standard error. When you put the t star in front, that makes it the margin of error. So all of these, whenever you put the t star or z star in front, this one, if you put a t star in front, you have the margin of error. These, if you put a z star in front, you have the margin of error. Okay, so this is x bar plus or minus the margin of error. If we're doing this one, a lot of those things show up on the calculator after 41.28. The t star, we had that earlier. It was the 2.44 that I wrote on there, and then times s, which is 7.54, divided by the square root of 7. Get a little bit of that on there, 7.54 square root of 7. I think that t star was something like 2.44. I'm not going to get the exact amount. And then this over here was 41.3. Okay. So a lot of times they give you those values, but we want the margin of error to be reduced to 3. So 3 equals. Now, one thing, whenever you're calculating a sample size, we were using 95%. So you never will use the t star. Because you're calculating sample size, you go with the most conservative estimate, which is the z star, to calculate that. And we had a standard deviation of 7.54. Over the square root of n. You got to solve for that. Square root of n will equal 1.96 times 7.54, 5 by 3, and then we have to square it. And squared. If I did that right, we need a sample of at least 25 to get that done. Okay. Next one, difference in means. All right. So this, in terms of what is the parameter we're looking for the difference in the two ambulance times. We got ambulance company A and ambulance company B. It looks like A is a little bit slower or a little bit faster, I guess, because it's their response time in minutes. So they're about a minute faster. So that would result in a negative. But let's jump in. Again, whenever you do the two sample one, you go random independent groups. Now I have all those on that last page. I'm not going back and forth to that last page, but the sample size on this one, the t-test, we justified it by looking at a graph. The sample was only 7. It wasn't big enough to be normal. If you have a sample of 25 or more, now some books say 30. Be prepared for that because one of the review tests that I saw, it used 30. But 25 is about as small. We just go with the small value of 25. Don't go below 25 to justify normality. This one is a sample of 45. This one's a sample of 32. Those are both bigger than, whoops, I put 10. Sorry. Get that out of there. Both bigger than 25. So it's nearly normal. I am 90% confident the true difference in means response times is between. Now, what test are we doing? We're doing the 2 sample t-test. I have it a lot where students will do a 2 sample z-test. It's not a z-test because these standard deviations come from the population. Okay, so we have to jump in here. Menu 6, number 4, the 2 sample t-interval. This time we have the stats. And what's the difference? You didn't type anything into a list. Okay, so we got to get that in. 12.4, 2.2, 45, 13.4, 3.3, and 32. And we wanted 90 or 95, 90. And as a rule, never pool. Only one time we have something on the AP test where it says the pooled test statistic is a p-value of 0.03. What's your conclusion? If you hear something about pooling and they give you a p-value, ignore the pooling part. And if you got a p-value of 0.03, say it's less than 5%, I'm going to reject the null, whatever the null is. That confused my students as about 10 years ago that happened. But we're between negative 2.12 and positive 0.12. So notice 0 is in the interval. So is there evidence that one of the ambulance response times is less? There is not from this situation. Okay, now the paired t-interval is the same as the t-interval. It is a test for means. The first thing I would do is I would get all these values. Now I usually make the rule is after minus before will make more sense because here we've got something they're cooking a vegetable and that negative 10, if I do after minus before, it makes more sense because it lost vitamin C, lost vitamin C, lost vitamin C, stayed the same. Lost vitamin C, lost vitamin C, lost vitamin C, stayed the same. And then we got to get these in. Then we got 2 negative 10s, 4 negative 5s, and 2 zeros. Sorry, I didn't get these in. We'll call this one D. All right. They don't have to be in order when you type them in. In terms of the graph, probably going to be a little goofy, but menu 1.4, it still looks fairly straight. We've just got what's called granularity, repeat measurements. Okay, so a 90% confidence interval. Always do your assumptions if you're doing a confidence interval. Random, independent. Nearly normal. I just made a normal probability plot sketch. I'm going to do a paired t-interval. Now, when you do these, why are they paired? And it's random paired data. We usually don't do the independent one because people get that confused. They're not really independent of each other. They are paired because there were 8 samples. This is one store. This is another store. There's a reason those 2 numbers are paired, so we get it down to 1 difference. I am 90% confident the true difference in vitamin C after minus before is between, then it gives us a couple numbers. We're going to use the stats. And use 662. We just used the T interval on this one. On data, our list is D and do 90 or 95. 90. Negative 7.5 and negative 2.46. Now, of course, this one, it would be X bar plus or minus T star times S over the square root of N. In terms of T star, we have 8, so you'd look up degrees of freedom 6 on your sheet to figure out T star if you have to fill that in. I don't think I did the formula for this one, but that's the formula, X bar 1, X bar 2 for the one before that. All those are on there. It will benefit you to study those. If you do one of the practice tests that I've released on AP Classroom, hopefully you familiarize yourself with those formulas and that helps. Thanks for watching. Have a great day.